Now I am taking an example after discussing a lot about the number system, all about rational, irrational, terminating, non-terminating, natural, whole number, integer. The question is how to insert few rationals and few irrationals between two given numbers. As we know, if there is a number line, every point of the number line stands for some rationals and some irrationals. Now the question is that how to insert, that is find 7 rational numbers between 1 by 6 and 5 by 21. We have two numbers. First number is 1 by 6 and the second number is 5 by 21. What we actually need to do, we want to find 7 rational numbers. 7 rational numbers between this and this. Before it, I would like to tell you, between two rational numbers, there lies infinite number of rational numbers. If you have any two rational numbers, as much closely as you can write, but we have a property that order of rational numbers is dense, meaning by between any two rational numbers there are infinite rational numbers can be inserted. You have to remember this property, number 1. Then question is here, a very short example. We have two rational numbers, one is 1 by 6, other is 5 by 21. We want to insert 7 rational numbers between these two. We may insert 7, we may insert 70, we may insert 7,000, 7 lakhs, 7 crores. Whatever number of rational numbers are required to insert between two rational numbers, we can insert. But before it, as you know, numbers, that is rational numbers, are the numbers in the form of P by Q, where P and Q are co-prime, Q is not equal to 0. P by Q, 1 by 6, P and Q both are integers having no common factor. So first one is clearly what? Rational. 5 by 21 is also what? Rational, because P by Q, P is 5, Q is 21. Here P by Q, P is 1, Q is 6. None of the condition having Q as 0 and no number is common. So we can say these are the rational numbers in its simplest form, because P and Q are co-prime. Meaning of co-prime is well explained you, that if HCF of the two numbers is 1, two integers is 1. Before it, we have to make their denominators same. As and when we want to insert some rational numbers between two rational numbers, their denominators. Here denominator is 6, here denominator is 21. What is such number which we multiply with this denominator and this denominator? That they become equal. So first of all, we will see that what is such number. To calculate that number, you can see that this is 6, this is 21. We will go to calculate LCM of 6 and 21. 6 can be written as 2 into 3 and 21 can be written as 3 7 ja 21. LCM of these numbers become, because 3 is a common factor, then into 2 non-common, then into 7. So this becomes 42. LCM of 6 and 21 is 42. So its meaning that both the denominators or the denominator of both the numbers must be 42. It is possible that if I multiply this number by 7, if I multiply the denominator by 7, it is mandatory to multiply numerator also by 7. Now we have 5 upon 21 to make it 42. What we need to do, multiply it by 2, and we will multiply this by also 2, because I want to keep the number value of the rational number same. So this converts to 7 by 42 and this converts to 10 by 42. If only two rational numbers are required, I can say 7 by 42 and 10 by 42, they are two numbers. What are these? 8 by 42 and 9 by 42 can be easily written. But I am not interested to calculate only two numbers. I want to find how to insert the 7 rational numbers. Now how to say and what is method to find it like this? 7 by 42 and 10 by 42. Simplest form of 7 by 42 is 1 by 6. Simplest form of 10 by 42 is 5 by 21. But with this special trick, by finding LCM, we have made their denominator same. Now what we can do? We can multiply these two numbers by same number. That is, you can say 70 upon 420 and 100 upon 420. 70 upon 420, 100 upon 420, still these are what? Still these are same as 5 by 21 and 1 by 6. Between 70 by 420 and 100 by 420, it is easy to write many rational numbers like 71 upon 420, 72 upon 420, 73 upon 420, ... So, till what? 99 upon 420. So 71 to 99. 71 to 99, that is what? We can say I have inserted many rational numbers between these two. If you want to insert few more, you just can go to write it like this: 700 upon 4200 and 1000 upon 4200. Now there the space has increased between 700 and 1000. If you want to insert few more, you can say it is 7000 upon 42,000 and 10,000 upon 42,000. So we will multiply 10, 10, 10 and the gap will increase, so we can insert n number of rational number between any two rational number. But step is, first make their denominator same and then you multiply numerator and denominator by some natural number according to as your requirement, how many numbers you want to insert. Between two rational numbers, we can insert any number of rational numbers as well as any number of irrational numbers. Now I am taking an example where between two rational numbers, how to insert few given number of irrational numbers. Rationals are those which are in the form of P by Q. Rationals are of two types, either terminating or non-terminating but repeating. Irrationals are those which are non-terminating, non-repeating. So for making it clear, be with me to see this example. Insert 50 irrational numbers between 1 by 2 and 1 by 3. What is 1 by 2? 1 by 2 is a rational number. 1 by 3 is also rational number. So I want to insert what? 50 irrational numbers between 1 by 2 and 1 by 3. In order to insert 50 irrationals, it is convenient to convert both these numbers in their decimal form. You know it well, when you are going to convert any rational number in its decimal form, there are two types of possibilities. Type A, where the division will terminate, or type B, where division will not terminate. If division will not terminate, then it will repeat. After how many places? Or on before denominator minus 1. So we can say 1 by 2 is what? 0.5. It's terminating. Why it is terminating? Reason is so simple. Its denominator is 2. Prime factors of 2 are 2 1 ja 2. If the prime factors of the denominator having only 2s, only 5s, or both 2's and 5's, then it has to be a terminating. That's why we can say 1 upon 2 is equals to 0.5 is a terminating number. Now, what for 1 by 3? To convert this 1 by 3, denominator prime factorization, that is the prime factorization of 3. It is 3 1 ja 3. No 2, no 5, only a number 3. So the property is, if the prime factorization of the denominator of any rational number having any prime number other than 2 and 5, it has to be a non-terminating repeating. So but repetition begun with after how many places? Repetition begun after denominator minus 1 places or before it. Here denominator is what? 3. 3 minus 1 is what? 2. So if I divide 1 by 3, I will get a non-terminating repeating number, and repetition will begin either after 2 places or before it, that is either after 1 place. So you all know 1 by 3 answer is 0.3333 dot dot dot. Sometime few of you can write it as 3 bar, 0.3 bar, okay, having the same meaning. Here repetition has started immediate after 1 place, but in case this maximum, you see denominator is 3, 3 minus 1 2, repetition has to be started in case of the non-terminating rational numbers, denominator minus 1 places or before it. So here 3 minus 1 2, so repetition has started after 1 place, not after 2 place, because I am saying again and again, repetition starts immediate after denominator minus 1 or before it. So denominator minus 1 or before it, it is satisfying. I want to find 50 irrationals between 1 by 2 and 1 by 3. 0.5 is the decimal form of 1 by 2 and 0.3 bar or 0.33333 is the decimal form of 1 by 3. I want to insert 50 numbers between these two. So what can I do? I just can say 0.5 can be written as 0.5000. As many zeros I want to write, I can. And next is 0.33333 dot dot dot. It is terminating, so no dot dot dot. It is non-terminating, so I am putting dot dot dot. Question is, what is the number between 0.5 first place and 0.3? Yes, a number is 0.4. 0.4 is a number lying between these two. Now the question raised, I want to write how many irrationals? 50 irrationals. So I have to write 50 irrationals like this: 0.41, 441, 444, 1 dot dot dot, then 0.420, then 200, then 200, then dot dot dot. Similarly 0.4, you can say 2211, then 222211, then 222211. So you have to begin with what? 0.4, and then you have to write such a sequence where numbers will not repeat. Here 1, then 2 4, then 1, then 3 4. So no termination is there, no repetition is there, just a pattern. So you can write, as I have explained you how to write 3 numbers. Similarly, you can write 50, 100, 1000. You just need to write the first digit as 0.4, because 0.4 is coming between 0.3 and 0.5. So this is the way. It is not necessary that you will write the irrational numbers between irrationals and rationals between rationals. No, you can write rationals and irrationals between any rational or any irrational. Now I am taking another example where we will insert few rationals and few irrationals between two given numbers. Example is, insert 5 rationals and 5 irrationals between root 2 and root 3. it is very much clear that root 2 is an irrational, root 3 is an irrational. Because one can find their square root up to any places of decimal, no pattern, no repetition, nothing we can find in any of these two cases. That's why their answers will come in the form of non-terminating, non-repeating, and such numbers are to be taken as irrationals. What we want to do between root 2 and root 3, we are interested to insert 5 rationals and 5 irrationals. I am trying to tell you it is always convenient to bring the decimal form of rational or irrational when you want to insert few numbers between them. Here root 2, you all know in class 8 have been calculated many times and have been asked to you in the examination. 1.414 ... It remains non-terminating, non-repeating, and root 3 comes as 1.732 ... You have converted both irrational numbers again in the irrational but in the decimal form, because an irrational cannot be changed without multiplication or division in the rational, or any rational cannot be converted in the irrational without any particular multiplication or division. Same here, root 2's value 1.414 decimal representation and root 3 is 1.732 ... Now a question is here that how to write 5 rationals. To write 5 rationals, you see it is 1, it is 1. So you will say it is 1. Then point, 1 point. It is 1.4, it is 1.7. It is 1.4, it is 1.7. So you can see between 1.4 and 1.7, you can say it is 1.5, 1.6. We can say if you want to write what? Rationals. So you can write 5 rationals like this: 1.51, 1.52, 1.53, 1.54, 1.56. Whatever you want to write, you have to take care that when you are writing a number, it should be more than 1.4 and less than 1.7 and no ... Because we are trying to write what? Rationals. If you are trying to write ... then you have to write the pattern. So these are 1, 2, 3, 4, 5. Similarly, you can say 1.6, 1.61, 1.62, 1.69, 1.51, 1.567. You can write infinite number of rational numbers by just a little bit of the common sense, which start either with 1.5 or 1.6. Because these are the two values lies between the decimal representation of root 2 and root 3. These are the rationals. Same numbers, these all 5 can be converted to irrational also. How? If you want to say 1.51, then you write 551, then you write 551 and ... Then 1.52, 552, 552 ... Then you can say 1.53, 553, 553 and ... Similarly, you can write, as I have shown here, 3 irrationals. You can write n number of rational, maybe 5, maybe 50, maybe 1000, maybe 500. Whatever you want to write, you can write. But take care, when you are writing irrational, there is a pattern, non-termination, non-repeating. Whenever you are writing the rationals, the pattern should be either terminating, or if it is not, then you write them in the non-terminating but repeating. So this is the way to insert few numbers between the two given numbers. Now we will explain you. Now I will tell you how to represent the rationals and irrationals on the number line. Now I want to tell you how to represent the irrational numbers on the number line. We will use here the Pythagoras theorem. The concept of the Pythagoras theorem is very much helpful for representing the irrational numbers on the number line. See, basic, first, root 2. Represent root 2, root 3, root 17, root 19 on the number line. I am taking here 4 examples. With the help of this, you will become quite comfortable. First is root 2. So I have used a word theorem Pythagoras. How can I say that root 2 is what? Root 2 can be written as 1 plus 1. Or root 2 can be written as 1 square plus 1 square. Still root 2 is the same. It has the same value. Question raised, what help we want to take from here? The simple reason is, we know that hypotenuse square is equals to perpendicular square plus base square. Meaning by we can say hypotenuse is equals to root of perpendicular square plus base square. So if I equate, I compare, or I use some logic, this formula of Pythagoras with root 2, I say root 2 is equals to 1 square plus 1 square. So what conclusion I am going to draw? Conclusion is that root 2 is the hypotenuse of such a right angle triangle whose perpendicular is of 1 unit and base is of 1 unit. From this discussion, you must be aware that what is root 2? I want to say root 2 is the hypotenuse of that right angled triangle whose perpendicular and base both are of 1 unit. To express root 2 on number line, I am roughly taking a number line. Line is that line segment which is extended indefinitely in both the directions. Here this is the center, Aryabhata's number 0. This is the positive side, this is the negative side. This is positive side, this is negative side. Now I can say, suppose this is 1 unit, this is 2 unit, this is 3 unit, and so on remain to go. Similarly -1, -2 and -3. Okay. What I want to say that I want to draw a right angled triangle whose perpendicular and base both are 1. I have taken here 0. This is 1 unit. Suppose this point is what? Where 1 is written, I am taking this point as P. On this point P, I am going to draw a perpendicular like this. You know what is the difference between perpendicular and altitude? If you can, please tell us on the extra mind. So this is the P, perpendicular is drawn. What is going to be? What is the length of OP? This 0, I am taking this point as O. Same distance as is of OP. You have to cut it on the perpendicular by taking P as center like this. Suppose this is the point Q. I am repeating what I did. O is the center. OP is the distance 1 unit. Then another is maybe whatever, second, third, fourth, similarly positive and negative. Now with the help of compass, I have fixed that compass needle at O, opened it till P, meaning by this become 1 unit. This distance I have made cut off on the perpendicular which is being drawn on P. This point is suppose coming as Q. If Q is joined to O, now Q is joined to O, then what you can say? OPQ is a right angled triangle. Right angled triangle with base OP as 1, with perpendicular PQ as 1. So with the help of Pythagoras theorem, we can conclude its hypotenuse is coming root 2. Root of 1 square plus root of 1 square is equals to root of 2. Now conclusion is coming that OQ is equals to what? Root 2. This part OQ is root 2. This part OQ is what? Root 2. But actually it is not on number line. To bring this part OQ on number line, take the compass. fix its needle at O, open it till pencil Q, and then mark an arc like this. So we will get a new point, suppose M, which is somewhere between 1 and 2. This length OM on the number line represents root 2 because as the arc OQ is equals to OM. OQ is root 2 because of the Pythagorean condition, and OM and OQ are equal because of the compass and pencil. We have marked an arc, so the two radii are equal. So in this way, root 2 is what? OM. I have explained you how to express root 2 on the number line. Basic number, first number. In order to represent any irrational number on number line, we will always take the help of Pythagoras theorem. We will see that given number can be expressed in the breakup of what, and then that can be utilized with the base and perpendicular and hypotenuse. So come is the same irrational number, and with the help of compass, that hypotenuse can be plotted, converted, and search a point on the number line. I will explain you how root 3, root 17 and root 19 on the number